Hello, good morning, everyone.
Good morning.
So we give you some time to connect your cameras. Very good. Hello, good morning.
Good morning.
Good morning.
Morning.
So we have already 50 participants with us today. I think more will come. We are just about to start.
It is impressive.
Okay.
I'm very sorry. I guess my camera doesn't work at this time.
There is no problem.
Okay.
So because Zoom is a participatory software, I will just ask you, you can keep always your camera on, but I just ask you that you mute yourself so we can avoid background noises. Okay? And let's just give it one more minute because there are still people coming in. Okay. So welcome all to Europark webinar. My name is Barbara Pais. I am the Communications and Marketing Manager of the Europark Federation. And I'm very glad to have you here today. We have received people from all over the world registering. So from Europe, but also from the US, from Brazil, even from Australia. We will be today talking about climate change. But before that, I just want to show you how we can work with the Zoom. As I told you, please turn on your camera, but mute yourself. You will be asked to unmute during the webinar, so you can directly interact with our presenters today. And in your screen, you'll see the bottom bar. You can mute yourself here using this icon. And you can stop sharing your video, but it can be on as well. And then what I ask you is, whenever you want to ask a question, and this will be especially important for the discussion, I would ask you to please click on participants and click on raise your hand. So it's just participants and raise your hand. If you don't find it in the moment you want to make a question, you can also raise your hand. But I don't think it will be so easy for us to understand that you want to make a question. So please do that, participants, and raise your hand. Okay, we can move forward. So Europark is really proud to present this webinar. This is the first time or the second time we are doing a webinar on climate change, but from now on we'll be organizing a series of webinars on this topic. For those who are not familiar, the Europark Federation is a members organization, and we work with protected area managers from all over Europe. Our objective is to bring people together to innovate and to work for nature conservation. So our members spread all over Europe. We have members in 40 countries, so even outside of Europe. And what we do is we organize events and opportunities to bring professionals together and to make them exchange experiences. But at the same time, we have also many tools to help parks working with youth or with junior rangers. We have programs to support parks developing sustainable destinations with their local community, for example, with European Charter for Sustainable Tourism in Protected Areas. And we work also for transboundary cooperation. But apart from that, we have also an office in Brussels where we represent the interests of protected areas and we try to lobby nature policy. And that's why we have an office in Brussels, from where my colleague Olivier is talking today. Today we will have, you can move slide. Today we have 3 very special guests. So my colleague Olivier He is the project manager of our Life Nature Adapt. He will tell you all about it in 1 minute. And he's based in Brussels. Then we'll go to France and we'll hear Jean-Baptiste giving us the perspective of a glaciologist on climate change. And then we go to England and we'll hear Ollie explain us what they are doing on the practical climate change mitigation with migratory birds. So, having said this, please make sure that you keep your microphone muted, and I will pass you on to Olivier. Olivier will tell you everything about the project.
Good morning, everyone. I'm very pleased to have you here. So as Barbara said, I'm working for Europark. I joined the team to manage a live project that is called Naturels Adapt. I will try to give you a bit more insight on the project itself. And I will most of my presentation will really present the results of a report that we did earlier this year, which was quite successful because it expresses the perspective from over 500 nature conservation professionals. And so we did both online surveys and interviews to get to those results. So before I start, do you think protected areas have a role to play in climate change mitigation? So if you want to test the raise your hand option, please do. I'll give you 10 seconds. Okay. So
I see.
You know, yeah.
See, at least 3 people raised their hands.
That's not so much. Yeah. Well, whatever. The idea is just so you know for yourself. Actually, in the survey we did, 90% of the respondents said yes to that question. So there is something that we have to look into when it comes to climate change. We can't just ignore it. It might become central to our practice. So shortly, Life Nature Adapt. It's a LIFE project, 5-year LIFE project. It's supported by the LIFE program, but also the environmental agencies in France. We are 10 partners from France mostly and European partners. And basically the project is an experiment. We are trying to build from the ground up, and from the existing experiences, we are trying to build a methodology that would help protected area managers to integrate climate change into their management practice. So it's really about planning. How do we plan the management of our areas, of our sites, in the framework of a changing climate? That's one aspect, a main one. And the second aspect that is also important is that we are trying to build a community of people that are interested in the topic, that are knowledgeable about the topic, and so we can facilitate exchanges and peer-to-peer support. So that's the project, very shortly. So among ourselves, what we talk about is vulnerability assessment. How do we assess the risk that climate change can put on our areas? We are talking about adaptation measures. So once we know the risk, how do we react? Do we react? Do we take actions? We are talking about a collaborative platform. So that's about, we are looking at a way to facilitate these community exchanges. And last but not least, we will be working on producing online courses. This webinar is part of this process. It's a bit of first, but we are working to formalize it. So what about this survey? As I said, we had 500 people who responded to an online questionnaire. You might be among them, so thank you if you did. It was very helpful because we could give us the big picture of the trend of how is climate change integrated in protected areas today. To complement that survey, we did a run of 10 interviews of people who had experience in climate change adaptation in protected areas. And so this is the results, and I will just share the key learnings. A report has been published in French. A summary has been translated into English. We are working on the translation of the full report, but we will let you know. So the first key learning is that climate change effects are actually observed. As soon as you start talking about climate change, there is a discussion, a debate. Well, that does not exist. Maybe it exists, but is it really climate change? It might be another pressure. So basically, what we hear from the professionals, the conservation professionals, is that they do observe it in their areas. What do they observe? The increasing of average temperatures, but also the increases of minimums and maximum temperatures. So all the effects of a change in the temperature patterns. Same thing with precipitations, prolonged drought, heavy rainfall, very concentrated. That's what people call extreme weather events, rising sea and ocean. So it's not only about the fact that the level of the sea is rising, is that there are more occurrences of storm surges, big storms that destroy either the coast or the infrastructures. Soil erosion is a big one that also linked to the fact that we have prolonged drought and heavy rainfall. And then one that is very interesting and very difficult to analyze and work is the disruption of the seasonal and phenological cycles. So basically, all the ecosystem cycle is impacted and so has to adapt. The main question will be, does the system have time enough to adapt, or the change is it too abrupt? So we will see that later. So the second learning is that climate change is definitely a priority for respondents. The number of registrants today show that there is a concern, and it's important in the short term. So this is important to understand. The respondents really highlighted the fact that even though climate change is a priority, it remains secondary to our usual pressure, I would say, which is the destruction and alteration of the natural habitat. I think both pressures are very intertwined and must be dealt with together. So we know now that climate change is a problem, that we have to take care of it or care for it. Then what we found out is that basically it's taking climate change into account, or climate change adaptation, if you want to phrase it in another way, is still an emerging practice. Actually, only 22% of the people we interviewed have done some kind of vulnerability assessment. If you talk about detailed vulnerability assessment, it goes down to 7%. So it's not much, but it's work that we can build upon. So innovators are at work. Just if you're interested in the topic, look for them, talk to them, and that's the fastest way to move forward. So there are many benefits to do this risk assessment. I'm sure you know about them, but so it helps you develop awareness campaigns, establish more monitoring. It's very specific to climate change, designing adaptation plans, and one that is quite surprising, it helps you develop new partnership in the territory. This is what we've learned from the people who have experience. Each experience is slightly different because it's very specific to the site and the area or the ecosystem you work in. So how do you adapt to climate change? Basically, it's an iterative process and it will remain like that. I don't think it's a news. Nature conservation was an iterative process. So the thing that might be changing is that it's the rhythm to which we have to adapt. And so basically what I mean by iterative process, you try, you learn, you adapt, you try again, and you learn again, and you try again, and so on. Climate change, what it does, basically it brings more change than we were used to. So maybe we will have to adapt a little bit or to change the way we manage protected areas. So if we want to design a methodology, we will have to do that on paper, obviously. And so we will have to find a way to make it linear. So I did draw big arrows to show that it should be iterative and circular. But basically, you start with a good reason to look into climate change. In some cases, it will be a traumatic event, a storm, a wildfire. Sometimes it's a manager that is very interested in the topic. He believes it's important. Sometimes it will be an imposition from the authorities. But you start from somewhere. And that's very important because it will it will how do I say that, give the direction of your process. Then we are researchers, or most of us are researchers, so we'll do some preparatory work, bibliographical research, meeting experienced people. All this will really help you imagine the future. Then the next step, and that's the interesting one from what we've heard, is that you have to imagine the future of climate. And that's not something scientists like to do, because scientists want to be sure, they want to have certainty. Here we have to do a projection based on of what we know. And so this exercise of imagining what will the future climate look like is a difficult one, but it's a necessary one, it's an important step, because you will, it will guide you towards a number of actions and not others. So once you know that, based on this assumption, you do a vulnerability assessment or different vulnerability assessments based on different assumptions. Then you move to improving your monitoring or establishing new monitoring. Then you move to planning and implementation. That's not new. And then you monitor. So that's very important to be able to learn and adapt more swiftly. I will end my talk. So there is a bit more in the report. Obviously, I can't go into the details, but I want to finish with the question that we asked about the role we have to play in climate change mitigation. And I think climate change can be seen as an opportunity for nature conservation, because nature-based solution can be put forward on a political level. But so protected areas, they can help strengthen the resilience of a territory from an ecosystem perspective. They can help being observatories of climate change. We have the staff, the trained staff, the scientists that are looking at the changes, that have the data, that have access to that data. They can really know how to analyze it. So our work is really to translate this knowledge for the stakeholders so that it's understandable for them. Then it could be a space for experiment, for the sustainable transition. And finally, it's definitely a space where we can raise awareness about climate change, showing the impacts, okay? So I think Jean-Baptiste in his speech will definitely show us how awareness can be raised. So a final word, but that's a word from the field. That's Kathy Hopley from the Forests of Bowland. Basically what she says is, even the path is uncertain, we should just go for it. Climate change adaptation is very interesting. It is a journey that we have to start now, and it's much simpler than it appears. So that's the end of my talk. I will give the floor to Jean-Baptiste in a minute. If you are interested to get involved, just contact me. Here are my my details, basically. Thank you very much for your attention. Jean-Baptiste, the floor is yours.
Thanks. Okay, so I share my screen now. Okay, so good morning, everyone. I'm Jean-Baptiste Bosson, so I'm going to present a brief introduction to past and ongoing climate change from a perspective of a glaciologist. So first, to introduce myself, I did a PhD a few years ago at the University of Lausanne in Switzerland on the evolution of Alpine glacier. And now I'm working as a scientific officer for the 9 protected areas of Haute-Savoie, so that's in France. I'm working with Olivier on the program Naturels in this job. And I am also a World Heritage Officer for the International Union for Conservation of Nature, and I especially led the first study on the World Heritage Glacier. So I'm going to present it a bit later. So in this webinar, I'm going to present things in 3 steps. The first, I'm going to define climate and glacier and see the relation between both. And then we are going to see how we are shifting from recent and natural climatic fluctuation on Earth to climate change at the Anthropocene. So I'm going to define also this term. So first, the climate definition. So because there is, so we can see, if you see my mouse, we can see the climate as the systems where the atmosphere, the hydrosphere, the cryosphere, the lithosphere, and the biosphere interact always. And because of these interactions, in each point of the planet, the atmospheric conditions are continuously varying. Okay. So to define the climate is the statistical distributions of these conditions for a given period and for a given region. So to define a climate, we need to have a large data set to find some kind of main characteristic and to design a kind of typology. And that's not the same things that weather, which is only the short-term characterization and predictions of these conditions, but for very short-term and for very small surfaces. Okay. No, the glacier. I think most of you know what are glaciers, but maybe a small reminder. So glacier are, but we need two key elements for glacier. That's the mass of sediment areas. Ice, that means that we need some snow that will compact and then transform into ice by crystallization. And then this mass flows downhill on the surface of the planet. So basically a glacier has two main areas. On the top part was the accumulation area where the snow accumulates and then transform into ice. And then it moves downward up to place where the climatic conditions are not favorable for the accumulation of snow all over the year, and even contribute to melt a part of the ice. And so the glacier is its geometry depends on what is going to accumulate as snow over a year and what is going to melt over a year on the lower part. So that's why the glaciers are some of the most the most efficient climatic indicator on Earth. They are very sensitive to each climatic variations in terms of temperature, of precipitation, snow, etc. So when the conditions are favorable to the glacier can advance and gain some volume. And when the conditions are not favorable, the glacier retreats and shrink. Okay, that's pretty basic. If we look at the distribution of the glacier and ice sheet on Earth, they cover more than around 10% of the land surface currently. So we have, of course, the two main continental ice sheets that are the Antarctica and the Greenland, and all the black dots that I put on this map, they are the 2,000 glacier that 200,000 glacier that we are on Earth, and the volume of all these glacier and ice sheets correspond to 66 meters of sea level equivalent. It means that if the glacier would and the ice sheet would melt instantaneously, the global sea level would rise of 66 meters. Okay. But of course, most of this volume is stored in the two continental ice sheets. Most of the volume in Antarctica, almost 90% of the volume, and 10% in Greenland. And all the other glaciers on Earth, they only store 0.5% of this global volume. That corresponds to 32 centimeters of sea level equivalent. But, okay, globally, that's not so important for the sea level, but at the continental scale, they are very, very important water stores that deliver water downward all over the year. And if we look the relation between glacier and climate, so the glacier and ice sheet, they are very key component of the climate system of the Earth because they influence, they cover 10%, they are white mostly, so they of course influence the reflection of the solar radiation, they influence the marine current, the marine level, etc. So they are very, very key component of the global climate system. But glaciers are also archived because they store, as you can see there, some bubble. So when we analyze bubble, we can reconstruct all the condition of the atmosphere. So that's a record of a proposition of record of temperature evolution of Earth over the last million years. And what we can say, just looking at this diagram, that the Earth have already been colder than today. We are here today. The Earth has already been colder and warmer than today. That's the first thing important to remind, maybe. So now we are living currently this period, which is called the Quaternary period. That it started 2.6 million years ago. It started because of two main phenomena. First, the closing of the Panama Isthmus, and second, the position thanks to tectonic of the Antarctica, and then the formation of the two large ice sheets on Earth. And the Quaternary is especially characterized by the succession of the interglacial period and the glaciation periods. So we have almost 20 glaciation since this period. So now I'm going to present a bit this period. So we have, as I say, a kind of cycle between glacial period where the temperatures are low and the sea level is also low because most of the ice is stored, most of a large water volume is stored in glacier and ice sheet. And then we have, on the other end, we have the interglacial where the temperature are higher and the sea level is also higher. And we can also see that with the carbon in the atmosphere over the last 100,000 years. That's the variation where when we have low carbon in the atmosphere, that's the glaciation, and we have the interglacial when we have high carbon rates. So when we have some glaciation, we have very large glacier that are developed on Earth. That's an example for Lyon in France. That's the Alps, and then we have so ice caps that flow up to the plain. And during interglacial period, the glacier on Earth, they are constrained only in the cold region, like the Alps currently, and the system change. Okay, now if we go further, as you can see, we are now living in interglacial since 11,000 years. The name of the interglacial, maybe you already heard about that, is the Holocene. And if we look now at the Holocene, the climate was not stable at all. That's a lot of variation, and that's the global mean in black here, in bold black. And we can see that there is a lot of cold and warm pulse that changed the system over the last millennia. Or maybe I didn't say why we are the cyclic succession of glaciation and interglacial. That's because of very frequent and variation of Earth's orbit and inclination. That's why we have this kind of regular circle. And now if we look at the Holocene pulse, most of them are related to slight variation of orbit, solar activity, and volcanism. So that's natural factor, okay? And so we have some period with warm fluctuation where the glacier were approximately at the same size that they have now. And we have a period of cold climatic conditions on Earth, like the Little Ice Age in the last few centuries, where the glacier became larger than today. Okay. And now, if we go further and if we have a look on the modern period, so as you can see, the current value is there, 2016, and we are facing a global warming. The trends when we look at the air, the earth, the ocean, and this global warming is very rapid at the geological time scale. So now, if we look at the origin of the current global warming, I present you now, so that's the warming, and that's the variation of the other climatic parameter, the control of the climatic parameter over the last century and decades, and you can see that neither solar nor orbit explain the current variation, volcano note. And if we look at the three main natural parameters, they are not explaining what is going on Earth. Okay, and now if we look at anthropogenic factor, so that's land use as deforestation, for instance, that's the ozone production and emission, the aerosol in the atmosphere. And the greenhouse gas, of course. And if we put together all the anthropogenic factors, you will see that it is close to what is observed. And if we put together all factors, which are natural and anthropogenic, it is also close to what is observed. So there is a large consensus on that in the scientific world, that the modification of the global warming is mainly due to anthropogenic cause. But okay, there is a warming, but there is a lot of other climatic parameters that change. There is a modification of precipitation, as we can say in France, etc., etc. So there is an important and global climate change currently. So now if we look still at the origin, our species, the Homo sapiens, appeared few 100,000 years ago, and you can see that okay, we didn't modify the carbon monoxide rate in the atmosphere since the beginning, and there is a really recent acceleration of increase of this rate currently. So that's a period that some scientists proposed to call the great accelerations, when we look at some ecosystemic trends on Earth, at the methane production, the ocean acidification, etc. They are closely related with also a very rapid increase and recent increase of socio-economic trends. So basically, because of human activity, there has been a strong modification of the atmosphere composition, mostly because we have emitted a lot of greenhouse gases, the ozone, etc. We are also impacting biodiversity, land surface, etc. So we deeply modify the Earth and its climatic systems. So that's the main idea. And because of that, the scientific community proposed to say, okay, we are not anymore in the Holocene, the natural interglacial period, but we are in the Anthropocene, the geological and climatic period, with which is mainly controlled by human activity. So there was a lot of paper on that. We will find a lot of things on the Anthropocene. And if we look at what is going on, okay, the idea is that because of human activities, we have pushed the Earth away from its natural trajectory. And the key question currently related to global climate policies is that, okay, do we have pushed the Earth close to the natural pathway or very far away? And I will discuss it a bit later. So of course, because the Earth is globally warming, the glacier and ice sheets are strongly melting. So that's an example in the Rocky Mountains, where we can see, okay, in the last 30 years there is a large and major glacier retreat. For instance, you can see here. There is a large data set on that, and so the consequence is that the sea levels rise because the glaciers are melting. And if we see at the Greenland ice sheet, that's a topographical comparison between 2003 and 2010, and you can see that we have only some surface lowering. So the Greenland is also melting, and if we see at the Antarctic ice sheet, unfortunately, it melts faster than what the glaciological community was thinking. So that's the violet, the purple curve there. So globally, there is a global and accelerating glacier melt on Earth. And as a consequence, if we see the climate system and the Earth system, it's darkening the Earth surface currently. And it contributes to sea level rise. For instance, sorry, it's below my note. It's below the. The sea level increase of 23 centimeters at the industrial age. Okay, and currently the rate is almost a third of a centimeter each year since 2000. Okay, now if we look in the future, and I'm going to show you some of my research on the World Heritage Glacier, as this one in Alaska, and we are going to see if the glacier are kind of keystone of nature conservation in a changing climate. So first, maybe the projection, I think you are pretty familiar with that. That's the projection of the IPCC, the International Panel on Climate Change, and you can see that regarding the greenhouse gas emission scenario, the global climate, the atmosphere is going to warm at different rates. So just to maybe to understand that, okay, we have on Earth a natural greenhouse effects of 155 watt by square meter, and then the human they add the anthropogenic forcing is we add some greenhouse gases, so we add we increase this effect, and so that's the result there. They are constricted on what the human added in terms of greenhouse gases and what are the social and environmental consequences. So you probably know already that all the results can be downscaled in regions, by countries, etc. So for instance, that's what is going to probably happen in France if we look at the RCP 2.6 scenario or the 8.5 extra, and also for winter precipitation, for instance. So now the future of glacier on this topic. So I will present you the study I led on disappearing World Heritage Glacier. That's another example. That's the longest glacier in Europe, which is in Switzerland. So as you can see, it already melted a lot since the Little Ice Age. So now we try to, with my friend and colleague Matthias Huss, we try to project what is going to happen for these sites. And maybe if we just see globally what is going to happen, the key point is that, okay, whatever happened, we have already a major and a precedented global glacial decline. And our projection is that globally, that's the projection for all the glaciers on Earth, we are going to lose between 25 and 50% of their current volume up to the end of the century. So, and we are going to face glacial extinction in some regions. I think also we can also see this result that they are very alarming, but we can also see this result positively in terms of, okay, if we will see that there is different magnitude of ice loss, and in one end we can, okay, we are going to lose a lot of ice in all situations, but if we apply strong climate policy globally, we are going to curve quite rapidly the melt rate on Earth and find in the next century a new equilibrium. Okay, so we are going to lose some ice, but we are going to save also a lot of ice, and the consequences are very important. In the other end, we can have a kind of irreversible disappearance of glacier with a very large ice loss, even in the 21st century, that will increase all over the century, and it's going to be irreversible on Earth. So the key message is that, okay, the humanity is still in the position that can really act and limit the loss of glacier. So we have a very large thing to do currently by trying to limit greenhouse gas emissions. In this paper, we try to answer three simple questions. So why do we have to protect and save the glacier? The first answer is that we show that they are very key components of the Earth's ecosystems where humanity lives currently. So the glacier, as I said, they are the key control of the global climate, the sea level, the water flux on the continental square, etc. So if we remove them from ecosystems, the ecosystems as we know currently, they would completely change. So that's the new IPCC data on the sea level rise due to glacial melt over the next centuries. And the glaciers are very important. And if we preserve and save a large ice volume on Earth, we are going to keep the Earth close to its natural orbit, if I can say that. But if we are going to lose a large ice mass on Earth, we are going to launch irreversible process that will push and lock the Earth far from its natural orbit and in a kind of outhouse Earth scenario. So they are very very important. They are like keystone species for global ecosystems. So now that we know that we have to save them, we try to protect them the most possible. How can we do that? And of course, some people propose that we can use some tarp, but I think that's very very useless. We cannot put some tarp on the surface of 10% of the planet. Each year we have to do that. So, and by doing that, we are not at all trying to address the problem. We are not trying to address the cause of the problem, which is the global warming. So we have only things to do. That's a key message, that we have to limit the global greenhouse gas emission globally. And finally, how can we push to go forward on this mission to curb greenhouse gas emission? I think glaciers are very important indicator, and they are also very important for ecosystems. So we really have to use them more and more as to raise global awareness, to apply and accelerate climate change mitigation policies. So they have to be more and more used as flagship species. And currently in Switzerland, this week, the people can propose a new change in the constitution of the country, and so they have enough signature to do that. So the people next year is going to vote to inscribe in the constitutions to save the glacier in Switzerland, and so on, to save the glacier, to force the country to respect and to put in the constitution to respect the Paris Agreement, the commitment made during the Paris Agreement, and also to be carbon neutral by 2050. So glacier conservation is has to be a key objective and a leverage to face climate change. Okay, maybe I have a message now. So just to conclude, we are really living in a kind of key period where the scientifics wants the humanity, and the key message are the next one. The humans are on a collision course with the natural world, and we are destructing the Earth, our only home. And there is an emergency to change the trajectory of human societies and to find sustainable alternatives to the business as usual model. So basically, it means that we have to do everything we can to avoid to getting in this kind of scenario, because that's something that the humanity has never dealt with it before. So we have to pass from commitments to decisive action. I think there is a lot of climate strikes that want to push forward all the action now. And I think that in this context that the protected areas has a very key role to play, as Olivier told before, because we can do a lot of mitigation, adaptation, and awareness action in protected areas, and we really need protected areas to face climate change. So just to conclude, the take-home messages of this presentation is that, okay, change and climate change are the norm at the geological time scale. But the specificity of the current climate change is that it is mainly anthropogenic, so due to the modification of energy exchange in the climate system by human activities. The global warming has already an important magnitude and velocity. Okay, there are already major consequences on Earth. Already, Olivier also gave some example before. And now, according to human activities in the near future and currently, we can maybe choose toward, on one hand, a new climatic equilibrium that solve the issues of the climate policy on Earth currently, or we can push and lock the Earth in a kind of outhouse. So that we are really facing a kind of decisive period for that. Okay, so thanks a lot for your attention.
Thank you very much, Jean-Baptiste. This was really, really useful. It made us understand what are the impacts and especially what are the anthropogenic causes for climate change. Jean, maybe you can stop sharing your screen. Yeah. And we can go to discussion mode, exactly. And one thing very important that you said is how to curb emissions and how to make policy work. So we believe at Europark that protected areas can play a very important role, and that's why the Naturels project is there for to help protected area managers implementing management plans that will allow them to a better adaptation and mitigation measures. One of the points is also restorative measures. So we have invited Ollie Watts from the RSPB. Rolly is sharing now his screen. And Rolly has been working on climate change for over 20 years. And you will tell us from a practical perspective, how can we think not only on restoring our sites, but also how to think outside of the box and at a larger scale for the benefit of different species. Ollie, the floor is yours. Thank you very much.
Thank you very much, and good morning, everybody. I've just had my talk introduced. We're a little behind time, so I will be a little faster than perhaps I'd hoped with the number of slides that I've got. But I want to focus on managing nature reserves for new weather, for the climate change situation that has been described that we're now in. And my slideshow is not moving for some reason.
Just click on the PowerPoint. Yeah, and now
there we go. Excellent. So we've heard that, thank you. Our protected areas are changing. The world around us is changing, but the rate of change is accelerating due to climate change, as we've just heard from Jean-Baptiste. Birds are already responding across Europe. I work for the RSPB, Royal Society for Protection of Birds in the UK, part of the BirdLife Partnership, so birds are a particular focus for us. What this graph shows is that bird populations, we've split them into two groups broadly. Those that are expected to do well from climate change in red, because they're warm adapted, and the colder adapted in blue. And we can see there's a change that's been apparent that really probably started in the late 1980s. And that time is common with a lot of observed trends of climate change across all sorts of things. That's what's happening now. We've also looked at the future and modelled the future distribution of Europe's breeding birds for a 3-degree average global temperature rise. And we found that the startling range shift of nearly 500, or just over 550 kilometres northeast. So in British terms, that's from the south coast almost up to the top of England to Newcastle. Only a 40% range overlap with where they're found at the moment, and a 20% range contraction. So our breeding birds will have a lot less area to live in. This is one of the maps from that atlas, and it shows how ranges will shift and how we need to think about where the important places for particular species are. So I picked the Dartford warbler because it's good for England, a toehold in southern Britain. At a 3-degree world, we see that actually England becomes part of the main population centre for the bird under a 3-degree rise. This is extracted from the EU guidelines from Natura 2000, and it simply shows that our Natura 2000 sites are vulnerable from one pressure resulting from climate change, an overriding picture of vulnerability there. As Jean-Baptiste particularly had shown, the warming that we've had, that we're now experiencing, is a relatively new phenomenon. It's really only the last 3, perhaps 4 decades that we've seen. So if we're only just starting to pick this up, it's not surprising. And that reflects the emissions that have really ramped up since the late 1950s and early 60s. It's a relatively new phenomenon, although the Industrial Revolution, which is obviously the origin of all this problem, has been going on for obviously a lot longer. But this is a modern phenomenon. The extent of the phenomenon is considerable, and this graph simply, the curve shows the average maximum and minimum temperatures in England, and the red and the blue lines show how the summer we had last year, which was a warm one in the UK, changes by the norm, and the degree is quite significant. I think if you look, sorry, get my pointer. If we look around here, we're talking of around 15, 16 degrees, and here we're talking to 25. It's a huge change. This kind of summer we expect to be the norm in around 25 to 30 years. Again, going back to roughly 3-degree average global temperature rise and stretching that out to Europe, we can see that even those changes that we've seen in England that are quite significant are dwarfed by the change in summer in average temperatures that we can expect across Europe. And again, a situation of really great considerable precipitation change across Europe. Again, these are annual averages. They don't show the seasonal differences, which will be more extreme. So we've talked about 3 degrees. I think it's not in general awareness that 2 degrees is actually very close, and it's an important milestone on the trajectory of climate change. This graph shows we can expect to have a 2-degree world around 2040, so 20 years away. So it's clear that we need to adapt, but how? Olivier has given a very useful framework for thinking about it, but what kind of adaptation measures should we take? And we've identified 2 broad strategies. One is building resilience to keep things, if you like, as they are, to come back from the impacts of climate change, which I think you can regard as actions, very important actions against climate change. But given that trajectory of change, we also need to learn how to live with climate change and accommodate our life and our nature and our protected areas to living with climate change. The talk at the moment correctly is about nature recovery, getting back what we'd had, but we then need to evolve and move that forward to future nature, to thinking about what the best we can make for nature in the future will be. And again, I think Olivier touched on that idea of trying to imagine the future, really, really important. So now I'll shift to what the RSPB is doing, and a lot of in terms of our own natural areas, we manage around 150,000 hectares of land across the UK. And one of our cornerstones for what we're doing is some work that was done by Professor Sir John Lawton here quite a few years ago now, around 2010, I think. Some very broad principles for how nature sites should respond to climate change. And they're summed up: we need bigger sites, they need to be better managed, we need more of them, and we need more ecological connection between them. So we've taken those to heart in what the RSPB is doing. And he looked at Lawton looked at the UK, but we need to expand that also to an even wider scope for migratory species that move vast distances across the planet. They need feeding stops along the way, and of course, as well as their distributional shifts, we have to start thinking of in terms of where we see them, particularly as summer birds in Europe. We also have to think about the conditions they get during their wintering grounds. So 4 key actions, principles, if you like, that the RSPB has taken on for our nature reserves. First one, manage our existing sites really well and extend them. The UK is an island with a lot of coast, and we have a lot of coastal problems from sea level rise and other issues. So we need to defend our coastal sites until sufficient replacement habitat has been created. We need to create new areas of habitat. And finally, we need to think about translocating some immobile species, or species that have very poor mobility, because the pace of climate change is greater than that a lot of our nature will be able to respond naturally. We need to think about welcoming different species, and here is a collection of species that have all now started to reappear in some cases for the first time within England. This is really exciting and is part of a good news story for climate change, and I think it's good to have this open aspect, an open mind to some of the benefits against all the rather gloomy projections that we now find ourselves needing to live amongst. This slide is slightly complicated, but I think it's really important. Some research that's been done that shows that birds use protected areas to shift range. So if we think back to that 550-kilometer range shift for a 3-degree world, most of that will happen with birds finding protected areas first, establishing in them, and then moving out of those protected areas to establish greater populations in the wider countryside. That's what this graph shows, in that the dots are the percentage of the population that's in protected areas, so 100% here for the whooper swan when it first arrived in the 1970s, late 1970s. And then as the population grows, which the graph shows, the proportion of that population in protected areas declines. Doesn't mean to say they're not important, but they're really important for the establishment, for the movement of species. And you can see that through goldeneye, through little egrets, through Chetty's warblers. Very important still for Mediterranean gull and common crane in the UK. So that's about the natural movement of species. Some species need more help, and these are 3 species that we've been working on, to the smooth snake in the middle, the fen raff spider, and a cricket on the left. We started to plan on different timescales. Some adaptation requires a very short lead-in time, grazing management, vegetation cutting, annual control of water levels, for example. Others we need to think a lot longer ahead, recreating or creating new habitat, woodland, other long-lived, and habitats take a long time to reach ecological maturity, thinking about water supply, thinking about sea defenses. So there's 2 timescales. Now I'm just going to whiz through a collection of slides showing things that we've done on our nature reserves as adaptation measures to climate change. One is increase the habitat heterogeneity, to increase the variety of places animals live, the variety of microclimates. We've taken the microclimate thing to heart in some areas, and here we're creating, which is now created, a large S-shaped bank for butterflies to provide a huge variety of microclimates depending on what the summer conditions will be. That's in southern England. We've looked at extending pack size and increasing connectivity. So this chart shows our strategic acquisition and development plans around one of our sites at Minsmere on the Suffolk coast. We are planting now woodlands at higher altitude than they've ever been at our nature reserve at Abernethy in the Cairngorms in Scotland, thinking ahead to future climate conditions where traditional pine forest will be. Changing land use has forced us to move our conservation habitat areas outside of the areas where they used to be. The wetland area in the middle, the used washers, is now used for flood drainage much more than it used to be. So we're looking to create habitat that was in that flooded area alongside of it. We're looking at more innovative and flexible site infrastructure. Here we used to have a seawall that's now been replaced by a spillway at Havergate Island, which is producing much the same sort of effect with a little bit more leeway on the habitat that we've got there. For some of our areas, that kind of response is not quite adequate. So here we have a freshwater reserve on the Norfolk coast, where we have taken the decision to introduce a salt marsh element because the seawall was undefendable, and the freshwater is now safe, protected by a salt marsh, which has added actually diversity to the site. But even that is inadequate for some of the reed beds in that area, and we've actually created new reed bed inland for bitterns where completely safe from sea level rise. Water management is a big thing for us. The RSPB, a lot of our wetland reserves. In some areas, we've been looking at very small areas and allowing others to dry out on a small scale. On a medium scale, we've actually created a reed bed here in central England near Oxford, which is actually designed not as primarily as a reed bed, but for water storage for the wet grassland. And then another example at Frampton Marsh in Lincolnshire, where the reserve is in 3 massive compartments that have each of them very flexible water control that we can manage according to the conditions prevalent at the particular time. Our large-scale vision for nature includes a massive scale of wetland creation or recreation in Somerset, where a lot of those birds that I showed on the earlier slide are already starting to colonize. We're also thinking about future visions for nature and for people together. This is Wallasey Island on the east coast, where habitat creation here is particularly built, also considers flood management along the river for people and the communities there. And indeed, we've we've been working with the Environment Agency here to help people adapt. So this is primarily done for people adaptation, for the caravan park at the bottom and the community on just to the up here, but continue to protect those communities with a wetland that absorbs the impact from the sea. And taking this nature-based theme to heart, we've been mapping in the UK the carbon in nature-rich areas, so moving from adaptation to mitigation. And I think this is a really important message, that we need to think of our protected areas even more as nature-based solutions for climate change, for society's response for climate change, and for the other things, for the ecosystem services that our nature protected areas give us. So summarizing, the critical time for action is now. We are past the time when we should be acting massively already, particularly on mitigation. Adaptation now needs to pick that up. This is something for today. We're on a trajectory of change that we are not able to step out of. I think the 2 degrees Celsius is a really important milestone. We can expect that in 20, 25 years, but it's a milestone along a continual trajectory of change for the rest of the century. We need to think of nature recovery and then develop that towards the future nature, to imagining the nature in these future climate change. And we need to think more about our landscapes in the context of nature and for people combined as our use of the natural environment changes. If all that seems very daunting, I end with this one: all is possible. The change that we've seen this year over the last 12 months in terms of awareness of climate change is amazing. This is Greta Thunberg in August last year. Look what she's achieved in the following 15 months. Look what we can achieve in the next 15 months. Thank you very much.
Thank you very, very much, Ollie. So we are open for discussion. Olivier has shown us that we need to empower protected areas. There is a big will. Ollie, maybe you can stop sharing your screen so we can see again all our participants. Yes, thank you. So Olivier showed us that there is a great will for protected areas to pursue their role as climate change mitigators, but we need to provide them tools. Well, Ollie just showed us a very wide range of tools that stretches from habitat heterogeneity, from working at a micro habitat, but also at a macro level, planning at different time scales, change land use, include innovative and flexible infrastructure, and a wide range of other tools. I hope you found it interesting. We definitely found it interesting, and I'm sure there is a lot of questions popping in your heads. So if so, please raise the hand. You just click on participants on the bottom bar of your screen, and you can click on raise hand. So those I see raise hand, then you can turn on your microphone and you can say out loud your question, maybe introducing yourself first, where are you from, and then addressing the question to our speakers. If you cannot turn on your microphone, you can also use the chat box on the bottom. And to give you some time to think, yes, the presentations will be available tomorrow. They will also be sent to your inbox, and along with the recording of this session. So if you want to rehear it at any time, you can do it. So tomorrow we will have the presentations. Okay, so Olivier, there is a question for you actually in the chat. And this question was made by Array, and it's asked if you developed a computer model for imagining the future climate.
So as part of the project, we haven't. There are many research projects working on that. We call them climate services. So I can't give you a detailed response right now, but we've come across a number of questions. What it does not exist, and are looking for it, is the biodiversity response to climate pressure. So if there are changes, how will that particular species react? this is the knowledge gap that we face at the moment, from what I understand. But so, look for climate services that there are exist in every country. I know, but I don't have the names, the accurate names. But if you are interested, I can definitely do some, well, dig the names up.
Okay, thank you, Olivier. Is there any question? Well, there is a comment talking about adaptation measures, connectivity, heterogeneity. There are good opportunities to raise the profile in Europe in search of green infrastructure. Okay. Okay, so Marta from Fongobe, Europark Spain, tells us that the green infrastructure framework, it's a great opportunity. Can you share something with us, Ollie? You have shown us the green infrastructure example. Can you tell us, well, how have you been adapting infrastructure in your sites?
So in our sites, the infrastructure has, I think the biggest thing we've probably done is the wetland creation, creating new areas of wetland, and the infrastructure changes around the coast in terms of replacing hard coastal defences with soft coastal defences. I think in the UK we're actually quite slow at thinking about adaptation measures through nature-based solutions. There are some other flood measures, particularly up in the uplands around catchments, but I think many other European countries are actually much ahead of us in terms of urban infrastructure as well, which I think is an area that we should integrate, because with urban green infrastructure, it's a great opportunity for urban wildlife as well, creating new places for nature there.
Okay, thank you, Ollie. There is one question for Olivier. Yes.
Barbara, if I can add, on Marta's comment, what we heard from Cascais Ambiente, which is in Portugal, it's quite peri-urban, but still a third of their territory is a protected area. What they saw in climate change and planning for adaptation is that they could really reposition their biodiversity activities onto climate change actions, and it really helped create new funding for nature conservation and nature restoration. So basically, when we look at funding of nature conservation, it's mostly in the biodiversity pot today, but with climate change, there is an opportunity because there is a political will to invest in solutions, and parts of the solutions can definitely be protected areas or conservation work.
Does anyone have a different experience that you would like to share? So we can make it more interactive. If you have also implemented something in your protected area, you can also share with us. You're very welcome. We have very shy participants today. Okay, so I just move for another question from Christina to Olivier. Christina is asking if the survey will be available. You already said, but maybe you can repeat.
Well, yes, so the report is available in French at the moment. We translated a summary. We'll send you the link tomorrow. It's available on the Europark website. It's a 4-page summary. And we are working on translating the rest of the document. So you can already read the summary in English and the full report in French. We'll share the links in the post webinar communication. Exactly.
Okay, so we have a general question to all of the panelists. So, do you see a stronger participation of member countries from Eastern Europe in terms of developing protected areas across different neighboring countries? Well, this is a bit far away from climate change, I think. It does touch one point that Ollie said that it's very important about better connection between sites. But maybe some of you can say, go Ollie.
Yes, I think that's a really interesting point, because a lot of our legal structures are within countries, and we actually need to think biogeographically much more. And I know that's a little bit of a problem with the Habitats Directive for those countries that are in the European Union. And I think the graphs, the charts that I showed of the changing climatic conditions across Europe really emphasize that we've got to look at nature on a much broader spatial scale, and we need countries to work together much more. And perhaps the Eastern European countries are ahead of the other ones on that. So great, well done.
Well, within the Europark Transboundary Parks Network, so Europark has a program for transboundary cooperation, and we have members of the EU and non-EU joining forces and managing their land together. So we have an example of a trilateral park that involves Norway, Finland, and Russia. So even outside of the EU, they are cooperating. Certainly, we would like to see more parks cooperating across borders. If you have interest on the Transboundary Parks program, we can also send it on the outcomes of this webinar, so you can have an idea on how parks can come together. So there is a methodology behind that parks can implement and improve the management of their ecosystems.
And at the other end of the spatial scale, what we see from the interviews we did is that working at a regional level is a particularly efficient way, because it's very much, you are very much in the territory, living with the communities, having access to the political decision makers. And so basically what we have to do is work at all levels. That's not new to conservation, but so really developing adaptation plans and mitigation at a regional level that you can then put forward at a multinational level, so that you create all these connectivity of islands, and hopefully it won't remain islands for too long. So this is something that we saw, and that I think is interesting to a little bit review the way we think about conservation.
So building on what Ollie said during his presentation, not only planning on different timescales, but also at different range, right? So from regional to national level, and especially making use of the national policies for climate change that are there. We have a comment from Catalonia, and they are working a lot on nature-based solutions, and trying to make a lot of effort connecting different sites. Okay, it's difficult to explain to policymakers and investors. Can some of the panelists tell us something about it? How can we convince our policymakers and investors, both at the regional or at the national level?
I have, well, there is something that is interesting, is that basically to make such projects happen, you have to involve people. And today in our society, the way to involve people is to interest them with money. The problem with nature-based solution is basically that there's no money in play. It's quite cheap in the end, and it doesn't require so much effort and energy. And so it's much more difficult to say, well, let's all work together and we'll all have a return, a direct personal return. It's a common return, so it must be worked out a bit differently. But nature-based solutions are definitely solutions. We have to develop the expertise, we structure it in a bit of a different way. Today in Europe, the idea is that if you work for the common good, it must be free or paid by the public. And here there is a cultural change that is needed. I think I do believe it's happening. I've seen it, especially in the farming stuff. But it takes time. We are seeing that adaptation is on the way, but it takes time. So we just have to keep doing it. That's my take on it.
Can I add to that? Yeah, I think that's absolutely right. And I think, well, Jean-Baptiste talked about the humans are on collision course with nature and natural systems. And I think actually we're starting to realize that now and turn that back, and understanding how nature-based solutions can actually help us and put back the things that we've lost, I think will be more important in the next CBD targets. And the way the Sustainable Development Goals, but also it's a cheaper way of doing it 9 times out of 10. And a lot of the coastal restoration that we've been involved in, removing the cost of expensive seawalls, for example, and replacing them with areas which are larger intertidal areas to absorb the energy of the sea is one example now proven, and the proven aspect is a little bit difficult too. So we need to get on and do things, but they are cost effective.
And I think to add on that, it's a lesson learned by Cascais Ambiente again. It's basically work on the risk assessment, show the benefit of the solution and the cost effectiveness. So in some way, I don't say we have to go for capital, nature capital and so on, but in some way we have to be able to tell the decision makers or the stakeholders in their own language what would be the benefits for them. They won't work for the common good per se, but if they see that they can really benefit from it for their job, for their community, then they may want to act. And cost effectiveness in our liberal world is pretty much an argument.
Okay, we have 1 minute to go. I don't know if you still want to answer the last question. I think it's a very interesting question from Spain. And Octavio from CEO BirdLife is asking, well, he's saying that we expect from climate change that some of the areas, some of the natural values of the protected areas that were declared will be lost. In Spain, the law doesn't not allow to disclassify protected areas. So what could be the solution? If the protected areas and the natural values that we are protecting are no longer there because of climate change effects, what is the solution?
I think most of the protected areas that lose certain parts of their interest will gain other interest. And that hopefully will allow a re-notification of the sites or a re-notification of the interest of sites. But it's a really important question, and a lot of our sites are notified for fixed features that are of largely historical interest, and we need to understand and develop a new method of notifying sites in a robust way that accounts for the dynamism, for the changing nature within them. But I would imagine that certainly in the UK context, all of our protected areas will remain, and we've done some research on this, will remain important for nature. It's just that the specific interest of those sites will change over time.
Thank you. Olivier, you are muted.
We had an interesting discussion at the Europark annual conference last October on that particular topic. And one idea for the future, so it's not for today, would be to designate sites for the contribution to the resilience of the territory. So basically, you don't protect patrimonial species or assets, but you would protect well, biological processes. That's maybe the best way to put it, because then you protect a function and not an object anymore, which make it more difficult to put in a text, obviously. But still, that was a discussion. That was what it was about. I don't think anyone today sees how to do that concretely, but definitely there was an agreement among our small community that it could be a way forward.
Okay, thank you very much. So from protected areas to biological features, I think that's a very good mind swap. Okay, we should go. I just saw that Michael Uber has a question. Michael, if you can do it very, very fast. Just unmute yourself. Okay, you're unmuted. No, you're not. No, we cannot hear you yet. Okay. Well, let me just, well, he is there. Okay.
Okay. Hello, I'm Michael from Austria, and I have a quick question to Ollie. You have quite some impressive measures you presented to us. And actually, we are managing a Natura 2000 site in an urban area, so it's very limited in space, and we have strict boundaries. And for me, the question is, how did you deal with land ownership rights, spatial planning authorities, if you have these dynamic concepts of additional sites or creating new habitats, because things replant. So how did you experience this?
So I think I got that. You're breaking up a little bit. It's difficult, and you can have your idealized pathways of where you want to expand and develop sites, but a lot of it is about the opportunity of being able to get a hold of land and add it into our sites. In one respect, as an NGO, we're lucky in that we can buy things and acquire land without statutory designation or statutory requirements to be able to do that. But yeah, it's a mix of a desire list and an opportunity.
Okay.
Okay, thank you very much. Unfortunately, our time is up. But before you go, let me just share with you a very interesting opportunity to all of you. And this is the next SIGAN seminar. Wait to share. Okay. So I think you can see my screen now. So every year, Europark brings together professionals for a specific workshop on a specific topic. This is totally free for members, for Europark members, and it takes place every year in Germany, in the north of Germany. So next year we will be organizing within the framework of the project Adapt. We'll organize a seminar exclusively on the topic of adaptation for protected areas to climate change. So you will be here from this very soon. In January we'll open registration, so keep tuned. And meanwhile, next year we'll again start our our webinar series, not only on climate change, so there will be more webinars coming on climate change, but also on very wide range of topics for protected area managers. So keep tuned, we will inform you about all of it. And until then, have a nice holiday season, and we wish you all the best. So thank you very much for your attention, and see you the next time.
Thank you, bye.
Thank you very much.